Welcome to this tutorial on the basics of TinyOS. The topics that we shall be covering in this video are as follows. We'll start with a brief introduction about TinyOS, followed by the installation procedure on Ubuntu. Next, we'll set up the development environment for TinyOS using Eclipse and Yeti. We shall also be understanding the code structure in TinyOS and demonstrate a basic application. TinyOS, as the name suggests, is a small-scale operating system. It's free and open source, component-based operating system and platform-targeting wireless sensor network. TinyOS is an embedded operating system written in the NASC programming language, which acts as a set of cooperating tasks and processes. It all started as a collaboration between the University of California, the Intel Research and the Crossbow Technology, and has since grown to be an international consortium, the TinyOS Alliance. For installing TinyOS, we shall be using the latest version of TinyOS 2.1.2 on Ubuntu latest version 14.04 at this time, LTS. We recommend Ubuntu because of the various compatibility issues that arise because of Windows. This here is the official website of TinyOS, www.tinyos.net. It supports various communities and mailing lists which are really worth checking out. So let's begin with the installation procedure. Pull up a terminal, and the first step that you need to do is remove any previous or older versions of TinyOS that you might have. So use this command sudo apt get remove tinyos, specify the version that you currently might have, say 2.1.2, and hit enter. Since I don't have, I'll just erase it out. We also need to remove the previous version of the MP430 GCC compiler that you have. So use the auto remove command for it with purge option. And if you don't have any previous versions of TinyOS installed, you need not bother with these two steps, and you can directly start from what we are going to do now. So we'll install TinyOS from scratch. First, we need to add the TinyOS package from the Stanford University to our Ubuntu package list. So let's navigate to this file with sudo gedit etc apt sources.list. So type in your password. This is the file where we need to make changes. So scroll down to the bottom of the file and add in this line. You can comment it out for your convenience. So tv http://tinyos.stanford edu/tinyos/dists/ubuntu. This is it. So this is the main line that we need to add at the end of the sources.list file. We can just save it and close it. Make sure you have typed everything correctly here, and then we can just close it. So now we need to update the source list file. So we can use this command sudo apt get update, and the update has begun. This depends on your internet speed, so just bear with it. Okay, it's done. Now we need to install TinyOS from the repository we just added. Use this command sudo apt get install TinyOS and specify the version 2.1.2. So this might take a little bit of time depending on how fast your internet is. Confirm it again. As you can see, it's gonna take about 39 minutes for me, so I'll just pause it. Okay, it's done. Clear the window. And now let's change the ownership of this folder to ourselves or the current user. Use the command sudo chown, your username here, in my case it's Shreya, and Shreya again, and a capital R, make sure it's capital R, and we'll shift it to the OPT folder. So we are shifting the TinyOS 2.1.2 folder to the OPT folder here. So we are getting the ownership of it. Type in your password. And let's do the same thing again for the main folder. The previous step was for the subfolder. Your username. This is something we'll be needing later. Let's go back to the terminal. Yeah. And .r/opt TinyOS. Okay, made a small mistake. It's -r, not .r. So let's just rectify it. Okay, it's done. Now we have to add the variables to the environment. So we have to go to this TinyOS folder which we shifted to the OPT folder, and cd ls. You can see that TinyOS is in there in the OPT. Let's see now. Let's change the directory to the TinyOS folder, and let's check the contents of it. There are a couple of folders inside the TinyOS folder. We need to create a new file here called the tinyos.sh. So use this command. In this folder, we need to copy these contents. So just copy these codes and paste it here and save it and close it. Now we need to make some changes to the bash rc file. Okay, before that we can see that tinyos.sh has been added inside here. Okay, now for the bash rc file, let's open it. Sudo gedit /bash rc. It's a tilde, not a dash. And let's go to the bottom of it and add some code. These are the codes we need to add to the bash rc. This is for the environment pathing. Okay, we can save it and close it. Now we need to update. Okay, now we need to update the bash rc file. For this, we can use the command source tilde //.bash rc. Okay, it has been done. So TinyOS is all set up, as we can see here. So just few more steps. Now we need to compile the Java libraries that come with TinyOS. Now this $tossroot takes us directly to the TinyOS folder. So let's see the contents of it. Navigate to the support folder, then to the SDK, and then finally onto Java. And use this command here, sudo toss install gener. Here we are making the files so that they can be compiled later. It's done. So let's make it and Here we are just installing it and it's done. So now remains one final step for installation, that is we have to update our MSP 430 GCC compiler. MSP 430 is basically a microcontroller from the Texas Instruments. So the current version I have is 4.5.3 now. So we need to update it to the newest version. For that we need to remove this version first. So type in the command auto remove, sudo apt-get auto remove. Make sure you give the purge option. And confirm it, and this might take a while. Okay, it's done. Now we need to add the key to the newest version of the software. So here is the key that I'm adding. gpg-keyserver.ubuntu.com /recv-keys, and this is my key number. Just type it in, followed by this command. gpt-a-export, and again your key. It shows okay. So now we need to add to the source file again, like we did in the beginning of the program. So just open it, sudo gedit etc apt sources.list. Navigate to the bottom of the file. This is the line we added in the first step. Now we'll just add in these few more lines. Whenever you add something to a already existing file, it's a good idea to comment it out so that you can remove it later when you want. So this is for the GCC compiler. Just type in this dev http tinyprod.net repos, which stands for the repository. It's good name. Need to add few more lines. You can type it out again or just copy it and make the changes like I'll do now. So that's it. You can save it and go out of it. So this is the new part we have added. Okay. So now we'll install it. First we'll get the update, sudo apt-get update. Whenever we make changes to the sources.list file, we update it again. we install it. Use the sudo apt-get install MSP 430.46. Here we'll get the latest version of the MSP 430 GCC compiler by using this command. Confirm it again, and just wait. It might take a while, so 21 minutes. I'll just pause it and come back. Okay, it's done. We have the latest version installed now. So we just need to add few paths to the environment. For that we need to edit the bash rc file like we did earlier. Open it using the same command, sudo gedit /bash rc. It'll ask for your password, and we are here. Scroll down to the bottom of the file. And here is the changes we did earlier. We just need to add one more line to it. Export path equal to opt msp 430 46 bin $path. It's same as the previous line, but we are adding a new path here for the MSP 430.46 latest version. That's done. Save it, close it, and we are done. So we need to update it. So we'll just update the bash rc file, and it's done. Clear the window. Now we are ready to work with TinyOS. Let me navigate to the TinyOS folder using cd $tossroot. These are the contents. Oh, okay, I'm out of the folder. Let me go back to $tossroot. $tossroot takes you directly to the main TinyOS folder wherever your path is. So let's go in the apps folder inside TinyOS. Here it has few programs which already comes with the TinyOS packages. So to compile any one of those, all we need to do is give a make command. Let's compile the blink folder. Navigate to the blink, make, and what we need to give next is the name of the sensor board that we'll be using. TelOSB, let's assume. Let's set up the development environment for TinyOS. For this we'll be using Eclipse and Yeti 2. Yeti 2 is a plugin. So let me go to the download page of Eclipse. Just Google it up, and what you'll find is various options, the various IDEs which Eclipse provides. So right now the one which we need is right at the top for Java developers, and I am using 32-bit Linux. So put it for download. It might take a while. Select server, and it should automatically start downloading. Save it in your downloads folder, and it will take a while, so I'll just come back after it's done. Okay, so now it has been downloaded in my downloads folder. Right click on it, extract it here, extract here. So the folder that gets extracted will have the name Eclipse, this one. So before we do anything with it, we need few permissions. So type in this command in the terminal, sudo chown your username, in my case Shreya, /opt, and type in your password. So now we have the permission to paste it anywhere we want. in the desired folder. So let's cut this folder and go to the OPT folder for which we just obtained permission. It might be in your computer or in file system, and inside this just paste it. Let's open it and see the contents. This is the application. Let's make a shortcut of this in the desktop. So make link, cut this link and paste it on your desktop. And paste. You can rename it for your convenience. I'll just rename it to Eclipse. And press enter, launch it. For the first time, it will ask the workspace that we need to work in. Click OK. It's the work environment for Eclipse. So now let's get the Yeti plugin. Again, just Google it, Yeti 2 for TinyOS. This will take us to the official documentation for it. Just click on it. And the installation and guide is given on the project's website. So let's just go there. And this website is no longer maintained. So let's go to the installation page. And I'll just be following the steps given on this page, so you can refer it later. So what we need to do is actually copy this link. Right click on it, copy link location, minimize, and let's go back to our Eclipse. It's already open somewhere. Yeah. So now go to help and go to install new software option. Here add, type a name which is easier to understand later, Yeti 2 for TinyOS, and type in the link and paste the link which you just copied. Hit OK. What it will do is, it's taking a bit of time due to internet speed. What it will do is, it will show us the packages that are relevant. So we'll just click on the ones which we need. So if it's Ubuntu that you're using, ignore the Sigwin option, it's for Windows, and click in the rest, we shall be needing it. So these are all what we selected, and hit on next. Again, it's taking a while. So these are the things which will actually be installed. Keep hitting next, accept the terms of license agreement, and finish it. It's installing the softwares. Let it run for a while. Hit OK. It has some contents, it's fine. And we'll restart Eclipse now. Hit on yes. And it's all set up. We have the development environment set up with the Yeti plugin. Test it out. What we can do is, we'll check some program. Before that, make sure your perspective is set to TinyOS. Go to File. Let's import some already done projects. File system, go to browse. Let's go to the PT TinyOS, the apps that are already there. These are all the projects which are done. The Blink, open it. Go to project name, new one, and here we select from the various sensor boards. Okay, I already have a folder called new one, so it's showing an error. Just no problem. Click on it, source, and these are the contents of the source file. The blink app.nc. These are the contents which we shall be seeing in the next module. Blink C. If you just hover your mouse, it will show you the details. And the make file. We'll see in detail what actually these are in the next step.
Now we present to you an overview code of a simple program written in TinyOS. So we use the programming language named NESC. It's a programming language very similar to C, but it has slight differences. It stands for Network Embedded Systems C. So the NESC programming language is hardware independent, which implies that we can build different applications on different sensor boards. The developers also claim that the code written in NESC is very simple and it can be compiled very efficiently. Therefore, we will use this programming language to build applications in the TinyOS. So next we have components. Components are basic unit of codes in TinyOS. They are simple individual software pieces which are put together to build any application. Next is interface. Interfaces are very important parts of TinyOS. They are also called as wiring components. These components are connected to each other. Here we have component A connected to component B in the direction of component B. Thus it is unidirectional. We can also have it in the other direction. So we can have component B connected to component A but in the direction of component A. So we have it unidirectional. Next is app structure. App structure necessarily must have at least 3 files to build any application in TinyOS. The first being configuration file, the second one being module file, and third one being make file. So we place our code logic in the module file, and in the make file we tell the TinyOS compiler as to how to build the application. So we use these 3 files to build any application in TinyOS. Next we show you a simple program in TinyOS. It's a demonstration of the Hello World program. So we have Eclipse IDE along with Yeti plugin being launched. We use the Eclipse Luna IDE. So before we start building any application in TinyOS, we check if the open perspective is assigned to TinyOS. So we go to Window, Open Perspective, and check on TinyOS. Now we build the project. So we go to File, New, Project. We select the project to be TinyOS project. We give the project name as Hello World with H and W capital. So I type Hello World. The target or the sensor board being used to display any output will be TelOSB. So we select TelOSB as our output board. So now we are ready with the project Hello World. We have the SRC, that is source folder under Hello World project. We right click on it and select new and then select module file to build the module file. Now we give a name to the module file. It's basically the project name, that is Hello World, followed by the letter C. We use capital C as a convention to name any module file in TinyOS. Now this is the basic template for module file. Anything we build in TinyOS, we start with creating the interfaces. So we use the keyword uses followed by keyword interface. So I type out that. and then we use the Yeti plugin to get the interface name. So we press Ctrl plus space. So the Yeti plugin provides us with a list of interface names. So here we select boot as the interface name. This is basically done to first initialize or use the microprocessor. Next interface we use is the LEDS. We basically do this because we in this program are trying to output or show how we can switch on an LED light in the TinyOS output board. So when we hover the mouse over the interface name boot, we see that missing implementation is shown. So to add on the implementation, we select add boot.booted. So once we add it, we have the event being mentioned. So here we get event void boot.booted. So now to start implementing and to see a LED switch on the sensor board, we call on the function turn on LED. So now we have to do the implementation of this function. So we start off with that. We implement it by saying void turn on LED. Once we do this, we realize that the chip is ready to be used and the output board is ready to be executed. So we use the keyword called call to do this function of ours. So we have call dot LEDS. So we have LEDS dot LED on. LED on is a function which we will be using to switch on the LED on the sensor board. We can use any function we require. So for now we are done with the module file. So the next file we make is the configuration file. So we go to source, right click on it, new, and then configuration. We give the name of the configuration file as hello world followed by appc. So the convention followed to name any configuration file is with the project name followed by appc. So we're done with this now. So we get the template for configuration file. This is the basic template for it. So in the configuration part of it, we do nothing. So I just comment out by saying do nothing now. Next we have the implementation part in the configuration file. Here we mention the components which we will be using in this application. So the first component which we will be using is the main. So I type components and then control space. The Yeti plugin provides us with a list of components already present. Now since we want main C as the component, we type M and then we select main C. So the next component which we will be using is for the LED. So we have components LED SC. So this component is used because we are trying to switch on an LED on the sensor board. To connect these two components mentioned, we use another component. So I type out components and the name of the third component which we will be using, that is hello world C. So right now, since we already have the make file, so we're making this component hello world C as the name of the component. We use the keyword as when we have multiple components to name it. So here we will be doing components hello world C as app. So we can use the name app instead of hello world C wherever required. So the next step is to wire up the components which we have mentioned. So I write comment it saying wire it up to help you understand what we are doing. So we type app.boot arrow mark main C. So we are wiring up the interface along with the component main C. So here the boot is the interface and component is main C. Next we are wiring up the LEDS interface with the component LEDS C. Now we're done with the wiring part. So this is how our configuration file looks, where we have the components mentioned and we have the wiring done. We can also use directly Hello World C instead of app, but here we preferred using app instead of Hello World C. So we're done with the make file and the configuration file. Next we make the make file. So we go to source, new file. We give the file name as make file with capital M. That's the convention followed again. So this is how the make file looks. In the make file we mention the main components used. So we type out components all in caps, and then we have the name of the main component which is used. Sorry about the case, I'll just change it. It's capital H, ELLO, capital W, ORLD. So we have the components equal to the configuration. We have to include all the general rules required to make a basic application in TinyOS. So that's what we're doing here. We're doing include dollar in brackets make rule. So in this way we will be including all the general rules in the TinyOS application. So now we're done with the make file and module file as well as configuration file. So these are the three minimum files required to build any application. Now I'll demonstrate as to how to run to get the output. The basic command used is motelist, M-O-T-E-L-I-S-T, but since we do not have the output board to show the output, we do not have the sensor board, we regret that. So we see that when we give motelist as the command, we find no devices found. Otherwise it should be giving the devices which are plugged into the PC. We can change the write access to the device by saying sudo chown with the address name of the devices, but since we do not have the device output device, we regret that. To execute the application, we give the command make along with the sensor board or the target named which we had used while making the module file, that is tell OSB. Now done with all this, we can see the output on the sensor board. Now we just clear it up. Now I can demonstrate to you as to how we can have different functions being displayed on the sensor board. This program which we wrote showed how to switch on an LED. We can also switch off the LED. We can use LED off for that. We can switch and toggle the lights on the LED, so we can use LED toggle for that. So there are various functions which we can use to run the application to get various outputs in application in TinyOS. But these are the three basic files which we will require to make any application in TinyOS. So now done with this, I would also show you how the output will look on the sensor board. We've just captured a snapshot for you. So this is how the output looks on the sensor board. We have one LED turned on. So the light is on, we can see it's switched on. So this is how we can get the LED on. So thank you very much for watching our video. We hope it was informative and we had a great time presenting it to you. Thank you. Thank you for watching our video.
We hope we could give you a head start into building your own applications in TinyOS.
We would also like to thank Sangeeta ma'am for providing her valuable inputs.
We'd also like to thank the Department of CSC for giving us this opportunity.
Thank you.